So before we divide our patch up here, our space up into what I'm going to call UV space, I want to just review what we're doing here. We've got a plot, site boundaries, and we're going to put a building in it. So let's just represent that building right away. I'm going to look for a rectangle that allows me something simple, something by width and length. And there's actually a triangle there right now. And let's put a slider in, a number slider, that will allow us to change our building width. And we're going to make a square building just to simplify the project to start. So I'll make it go between 50 and 100 feet in increments of 1. And right away I'll number that, or I'll rename this, excuse me. And I'll call it building width. And like I said, we'll only use one number, so we'll come up with a square, and I will feed both the same parameters into the width and length. And there we have our box, and we can adjust that from 50 to 100 feet. But we won't just use this rectangle. I put it there for illustrations purposes. What we want to do is move a rectangle around this whole space and not have the building escape this space. So let's start looking at building this idea of what I'm calling a UV space. So I'm going to grab a special command, a surface command, that creates a point, surface.point at parameter. And this is a unique function. Actually, I wish I want to go back on that. I'm going to just retype that because I wanted you to see the graphic. Surface dot point at parameter. So what happens here, if you look at the output, it takes and creates a UV space, and I'll help explain that a little bit in the next few seconds here. But along a surface. So it defines a point on the surface by dividing that surface into a U and V, which is exactly the same as X and Y, except in this case, there's two unique things. One, it'll divide it between 0 and 1 for the whole space. So no matter what size the space is, from beginning to end, it's only divided between 0 and 1 in both the X and Y direction, or UV. And it can be any surface. It can be and most specifically, it's a curvilinear surface typically. We're in this case just using a flat surface. So with that kind of just start to explain it, what I want to do is just demonstrate how we can make this into a UV surface. So we need to grab this surface. We already have it here, and we need to define it. Actually, it's a curve right now. We need to define it as a surface. So we're going to change it into a surface by using a function that we're going to use quite often, and that's a surface by patch. I don't know if I type in, if I type in, start just typing in patch, it'll take a closed curve and generate a surface. And then we can put that surface into the UV space. And what I'm going to do right away is I'll turn this one off to preview, and we're just back to a clear space. And we have a point, and that point is right here. You can't exactly see it very clearly. And now we're going to manipulate it in what I call UV space. So we're going to use a number slider, and it's going to go between 1 or 0 and, as I said, 1, and we'll make it in increments of 10 or 0.1. So it'll give us, and if I put it into the U and I move this, you'll notice how that, you notice how that slides up and down, and that is the U direction. And right away I'll rename this. I'll right click on this and rename this node as the input, and I'll describe why I'm saying input underscore U. And I'll just copy that right away and paste it. And we'll make another one. We'll just rename this one V. And now we have a way of moving both the U and the V. So now if I slide this one over and I slide this one over, we have a point that we can move all around. And so that point is right here right now. I'll just move that in the V direction so you can see it again. Okay, so now we have the ability to manipulate the location of that point, and we're going to put a rectangle on that, which is this rectangle. And the way we're going to do that is we're going to define that rectangle as a plane, a point that has a plane attached to it. So bear with me for a second here. We're going to grab a tool which is plane by origin. Plane by origin with a normal. That just gives us a direction, and I grabbed the wrong one. So let me do that again. And we're going to stick that point into the origin. And we don't actually, the normal might be assumed already to be the z, so we don't actually even have to define that the vector axis is z. So if I was to hold the escape and kind of zoom in here a little bit, you can now see we have a plane about that surface. And now all I'm going to do is I'm going to put a rectangle around that surface. So we have rectangle, and we have it by plane, width, and length. So I can attach the plane to it, and I can go back over here and I can grab the, well, let me just pull this, I'll just pull this over so I can show you all clearly on the screen. We have that width and length that we can attach to it. And now I can get rid of the original descriptive rectangle that we were using. And now we have a way of moving our rectangle around the space. So let me hit the escape here and kind of tilt this down a little bit so we can see it better and zoom out. Oops. Zoom out. So now you can imagine that as being the building footprint. And if I now move the slider back and forth, we can control where the building sits on the site. But we have one problem, and that is where the building is exceeding at the 0 point. It is going past the plot line of the building, or exceeding the envelope that we want the building to be in. So we need to make a correction for that, and we'll pick that up in the next clip.